All right, so this is part 2 of our extra long rational root theorem problems. So we're going to do another one. This one I'm going to take pauses, and it is your job to try to do this problem on your own, and then I will give you the solution pieces along as we go. Great, so first thing for you to figure out, what are the 3 things we have to identify before we can even start this problem? We need to identify the lead coefficient, the degree, and the constant. So what is your leading coefficient? I'm going to call it LC. 6, okay, and your constant? Is 4, that's constant, and your degree is also 4. All right, the whole point of the degree is it tells you how many zeros you should end with at the end of your process. So it kind of tells you when you're done. All right, so step 1 is to do what? Okay. To list possible rational roots. What is that tiny formula for that? Plus or minus P over Q. Factors of constant over factors of lead coefficient. Constant here is 4, lead coefficient here is 6. All right, so factors of 4. 1, 2, 4. Factors of 6. 1, 2, 3, 6. Which is nice. It means that we have a pretty small list to deal with. All right, so let's list them out. All right. Oh, wrong color. Ha ha ha. Good grief. Okay, here we go. List. All right, I'm getting it together. Okay, so list them all out. I'll write them also. Hopefully your list matches mine. Make sure you use all of the denominators with each of those numerators. Okay, once you make your list, what do you need to check for? You need to check and eliminate duplicates. Or doubles, whatever makes you happy. All right, so whole numbers are always staying. So 1, 2, and 4. So do any of these reduce down to 1, 2, or 4? 2 over 2 reduces down to 1. 4 over 2 reduces down to 2. All right, 1/3, 2/3, 4/3, no. 1/6, no. 2/6, yes, it reduces down to 1/3. 4/6, yes, because it reduces down to 2/3. So one row below might reduce down to something up above. All right, so there's our list to do what with. What's our step 2? To test them. What do we test them with? Synthetic division. Okay, so test with synthetic division. Okay, you don't have to, but my pattern is to check this first column. Right, so start using synthetic division. See if anything from that first column, either a positive or negative 1, positive or negative 1/2, 1/3, or 1/6. Do any of those result in a 0? Right, if you checked 1, it shouldn't have worked. If you checked negative 1, it should not have worked. Alright, so try your 1/2. Pause it if you need to take a little more time, but you should be able to do them pretty quickly now. Alright, did either of those work? Alright, x equaling, negative 1/2 should not have worked, but yay, x equaling 1/2 should have worked. I'll prove it just in case, because if you go, I did 1/2 and it didn't work, I want to make sure you see that it does. Okay, so our coefficients are 6, negative 11, negative 16, positive 2, positive 4, and we bring down the 6. What is half of 6? Half of 6 is 3. Negative 11 plus 3 is negative 8. Half of negative 8 is negative 4. You combine those to make negative 20. Half of negative 20 is negative 10 plus 2 is negative 8. Half of negative 8 is negative 4. Combine those and woo, 0. That's what we want. You should be pretty quick with synthetic division, or if you're not, then it will just take you a little longer, but that's fine. You'll get quicker and quicker because you're going to do it a lot in this chapter. All right, so step 3. We're going to rewrite. In factored form. Okay, so using what we just found, so using this 0 information, what does it tell us? So since we found that the x value of 1/2 worked, what factor does it tell us we have? X minus 1/2. And then we need to use this synthetic quotient. So if we have 6, negative 8, negative 20, negative 8, what does it tell us? We started with x to the 4th, so this represents 6x cubed minus 8x squared minus 20x minus 8. Factored form is if you write those with each other. So this is an f of x, so we're going to use that same. So f of x, so this function can also be written as x minus 1/2 times 6x cubed minus 8x squared minus 20x minus 8. What is step 4? It's a question and it rhymes. Step 4, can you factor more? If you have a quadratic or higher, the answer is going to be yes. Can I factor more? It's a yes until you have simplified it all the way out into binomials. Okay, so always ask yourself before you go straight back to doing your 4 steps if there's a greatest common factor you can reduce out. If you did the teacher problem, so the part 1, there's a pattern to it. If you have x minus 1/2, then you are guaranteed a greatest common factor of 2 that can divide out. So we have x minus 1/2, and we're going to reduce our cubic polynomial by 2. So we have 3x cubed minus 4x squared minus 10x minus 4. So I reduced all those terms, I divided them all by 2 and factored a 2 out of those. Alright, you still have a cubic polynomial. So not only can you do that, but you can factor it even more. So you have a choice at this point if you want to try to divide it and group it. Only do that if you see that that will work pretty. If it won't, it's probably not worth it. So when you look at that negative 10x minus 4, if you can't reduce that all the way down into a pretty binomial, then it probably won't work so pretty for you. So since we're using the rational roots theorem, we're going to use that again. Alright, so we're going to say this is greater degree than a quadratic, oops, should be a cube, so guess what we get to do? Repeat steps 1 through 4. Yay, I know you're super excited about that. Alright, so we're going to keep what we already have, and we're going to take that cubic polynomial and we're going to do those 4 steps again. List the roots, test them, rewrite them, see if we can factor more. Alright, so we're going to pretend this is like our starting point.